Okay.
Okay, sure. So um, yesterday we looked at network devices and we basically saw a few of them and what they do on our networks. We looked at routers, we looked at switches, we looked at firewalls. We spoke a little bit on what clients and servers, and we saw all the differences and what they would actually do on any given network. Now, so for today's class, we'll be looking at basically cables and connection protocols. Because when we talk about devices, there's always a way, there should be a way we connect devices together for network connections to actually be what established. Because we know from the definition we saw, it was telling us that what is the interconnection of what devices, right? To a communication medium. So then we need some form of medium for the devices to be connected, and cables as one of the ways that that can actually happen. So in this particular class, we'll be covering the following. We'll look at some Ethernet protocols, that's specifically protocols that has got to do with cabling. We'll speak of the different types of wires that we have. We'll look at fiber optics. We'll look at wireless, and we might speak of how we get internet access, and then some proprietary links like serial connections. Okay, so let's get straight into it and start. So wires or cables. Now cables usually, when it comes to networking, come in various types. Usually we have twisted pair cables, which we'll see soon. We have coaxial cables. We have serial cables.
Yes.
Then we have the proprietary cables. That's when we say proprietary cables, these are specific cables that have been designed by manufacturers for specific type of connections, right? That's what basically proprietary cables are. So we'll see some of them as we go along the line. But before then, let's have a quick look at Ethernet. Right. So Ethernet. Now, when we say Ethernet, Ethernet basically is more of a standard or a collection of what of protocols. Okay, because I know this is not the first time we are hearing Ethernet, but most of the time, when you hear wire, the first thing that comes to mind, we always say what my Ethernet network, my Ethernet cables. Okay, so that Ethernet word we hear is basically a standard that defines all our cabling. Okay, it defines the cabling, it defines the different types of cabling we have, it defines how they are supposed to be what's terminated, the connection types, and all of those things are basically defined by the what Ethernet standard. Now, we all know that when it comes to data or when it comes to networking, what is actually being moved across our networks happens to be what? Data. Now, the smallest unit of data you can find on a PC happens to be what? Bits, that's binary bits. And when we say binary, it's either a 0 or a 1. Okay. However, when we want to give the smallest unit quantifiable, like we would call it what? 1 byte. Okay, so 1 byte is the least amount of data that you can actually what have on your PC. So this 1 byte is basically a combination of ones and what and zeros, and 8 of them actually would give you what? So 8 bits is equivalent to 1 byte. Okay. Now, however, when we send data over our networks or when we send data over communication mediums, that's basically our wires, we don't send data as a byte, but rather data is sent as bits, not bytes. That's how we basically send data. So you realize that data would go from one PC to the other in a fashion like this. So byte per byte, that's how, sorry, bit by bit, that's how data is basically sent across any connection medium. You will never be able to send one whole byte of data to another device. So you can't send it like this, like the way you see here. This is a byte of data. You can't send this whole thing across to this machine like this. It is not allowed. But rather we end up sending what? Bits of data. Okay. So the speed of data is usually measured in bits per what? Per second, and not bytes per second. Okay, so we are talking about the smallest unit you can actually send across any device. So always know that when we are talking about transfer speeds, it would be referred to in what? In bits. But when we are talking about data size that lives on our machine, then we can refer to those ones as what? As bytes. So storage would always be referred to as in bytes, or storage is measured in bytes, whereas speed of data is measured in what? In bits per second. Right? Sure. Okay. So let's see the different speeds and that we have basically out there. So the smallest speed you're likely going to have is what? 1 kilobit. And this is going to be what? Is equivalent to 1,000 bits. We have 1 megabit, which is equivalent to what? 1 million bits. We have 1 gigabit, which is equivalent to 1 billion bits. Then we have 1 terabit, which is equals to um, I didn't write this thing well. Okay, now this is supposed to be 100,000, that's supposed to 1 million, and that's supposed to be 1 billion. There should be extra zeros in there. And we have all the way into the pentabits and the hexabits and the zetabits and the yotabits. But we are not there yet. I think the common ones you're likely going to find would be anything ranging from a kilobit speed all the way to a gigabit. Even a terabit speed, hardly would you find transfer speeds like that, unless you're in some very supersonic data center. That's when you're likely going to experience speeds like this, but then you are likely going to experience anything from between a kilobit to a gigabit of network speed. Okay. Now, when it comes to Ethernet standard, the Ethernet standard is defined by the IEEE. Okay, so the very common, anytime you hear of Ethernet, I know the standard that comes to mind is the IEEE 802.3 standard. Now, this standard was basically purported in 1983 by the Institute of what? Electrical and Electronic Engineers. Now, everything in IT is standardized, and there are standardized bodies that handle all these things. So things don't just happen. Without standards, the IT industry would be a very chaotic industry. But then there are always supposed to be bodies that standardize what we do. And this also helps create things like interoperability, so that then I can have devices from other vendors work with other vendor equipment. So Ethernet is one of those standards that had to be what done, because then if not, we would have a lot of issues. So that's the first one, which is basically IEEE.802.3, which standardized our cabling for us. Right. Now let's look at the specifics of this standards when it comes to copper. You know, we have different types of cable. We have from copper, we have fiber optics, right? We have coaxial. All of them have their own standards that they would basically work with. Now, when it comes to the copper standards, specifically that's the I02.3, we have them starting from Ethernet. That's the least you can get. And Ethernet has a speed of 10 megabits per second. Then the common name would usually refer to it as what? Ethernet. The standard is 802.3i. Then the informal name, you would have it called what? 10 base T. Now, when we say 10 base T, what that thing means is, well, the 10 refers to the speed at which it works. The base there refers to what? The base band. And then the T refers to the type of cabling. So this is a twisted pair cabling. That's where this whole 10 base T thing comes from. Now, the maximum length you can get for any Ethernet cable happens to be what? 100 meters. Now, the next standard in that particular group is the fast Ethernet, which runs at 100 megabits per second. And the IEEE standard name is 802.3u. The informal name is 100 base T, and it's also 100 meters. Now, one thing you should know for your exams, especially, is for you to understand these standards, because you're likely going to come across them. And when you see that 802.3i, you should know what it is. When you see 802.3u, you should know what it is. If you are seeing 802.3ab, an, that should give you, like, it should give you that information. You should know what they basically would stand for and their specifications, right? So gigabit Ethernet is 1 gigabit speed, and that's the standard 802.3ab. Then we have 1,000 base T. It's also what, 100 meters. Then we have the 10 gigabits. That's the 10 gig Ethernet that has 10 gigabit speed. It's the 802.3an. And then we have the 10G base T, which tells you the speed is 10 gigabits and it's a baseband and it's what, a twisted pair cable. And it's equally what, 100 meters. Okay. Now let's take a look at our twisted pair cabling. So the very common type of cable you are likely going to see, or the twisted pair, I think this blue cable is a very common one we see around a lot. And when you are to strip any of them, this is how the cable looks inside. So it's made up of 4 pairs of cables. That's basically making what? 8. Depending on what type of cable you have and how it's going to look like. You can see these are all different cables. I have this here, I have this type here, and I have this one there. Now these are UTP cables. This UTP means unshielded twisted pair. It doesn't have anything, and specifically this is a category 6 cable. Then you have the shielded twisted pair, that's STP. You can see this one has a shield covering the wire. Then we have the Cat5, that's just the basic ordinary cable in there. Now, twisted pair cables come in various categories, okay? And it's very important that you understand these categories and you know the differences between them because they're not the same. Depending on what you're going to do, that would influence the type of cable you basically would what, pick up or decide to use. Now, let's take a look at the categories that we have. So with the twisted pair cabling, it starts all the way from Cat 1, that's category 1, all the way to category 7, and they have their own characteristics. So with the category 1 cables, these had data rates of up to 1 megabits per second. The maximum length is not really stated, and the cabling type is twisted pair. And the application, these were used for our old telephone systems, which are still available though. When you go to some offices where they still run the landlines, you realize those cables can really run very long. You see them all over the place. It's a category 1 cable actually, but then it's mainly used for phone lines. Some of them have just 2 cables in there. Others have what, 4 cables. So depending on what you're doing and what you are going to actually what see. Then we have the category 2, which basically can go speeds up to 4 megabits per second, and the maximum length is basically not specified. And it was used for our old token ring networks. That's the IBM token ring kind of networks, which is quite obsolete. Nobody's doing token rings these days. Then we've had category 3 that equally runs to 10 megabits per second. And the maximum length happens to be what? 100 meters. And it's a twisted pair type of cable. It's token ring and 10 base T Ethernet, right? That's where it starts from. Then Cat 4, kindly a minute, hold on. Yeah, sorry about that. I'm back. Yeah, sure. So, like I was saying, you would
Hello,
have
please can you explain the token ring network again? I
network for you.
didn't get.
You didn't get
Yeah.
that? Okay, fine. So, with the token ring kind of network, these were is an IBM proprietary kind of network where we used to have. When you say token ring, it means the network itself was like a ring topology where devices were connected in a circular form. So like if I have 4 devices, the first device is connected to the next one like that, and it forms some form of a ring. That's what token ring network basically happens to be.
Okay.
Right. You good?
Yeah.
Okay. Sure. Then we have, okay, so then let's follow up. We have the category 4, which is up to 16 megabits per second. And it was equally token ring. So anything from category 1 all the way to category 4, these are old technologies, and nobody is actually using them lately, except the telephone systems where you are likely going to see them, but nobody's really using these systems these days. Okay, so let's proceed with the category 5, which is a very common cable you would see in most of your organizations today. So category 5 has speeds of up to 100 megabits per second, and it can run a length of 100 meters, and it's twisted pair, it's Ethernet, and equally can do fast Ethernet, and can equally support token ring. Yeah, the likely applications you see them used for is your Ethernet and fast Ethernet, just for our usual Ethernet cabling, right? Now, with the category 5E, there was a need to actually get more speed, and the cable was improved a little bit. And a category 5E cable can give you speeds of up to 1 gigabits per second, and it can go a maximum length of 100. It's twisted pair, so you can see it supports these standards. So I have Ethernet, I have fast Ethernet, and I can use them for what? Gigabit Ethernet. Now we have category 6, right? Now with category 6, you can have speeds of up to 10 gigabits per second, though it is relative. It's not a very common type of cable you would actually see, and you have it running to up to 100 meters. It's twisted pair. It's for gigabit Ethernet, and it's for 10 gigabit Ethernet. Just that if I want to push 10 gigabits through a category 6 cable, the maximum length I can go with that type of cable is 55 meters. I can't get the usual 100 meters from it, which means if I'm doing 1 gigs per second, I would be able to do gigabit Ethernet. But where I have a compatible 10 gigabit Ethernet interface, I can't do up to 100 meters. I might only be able to do up to 55 meters, right? Then we have the category 6A, which can also go up to 10 gigabits per second. It's 100 meters, and it still supports the same thing. So it's gigabit Ethernet and 10 gigabit Ethernet. But even at that, that was still at 55 meters until we had Cat 7. Cat 7 is a relatively new cable. It's extremely thick, and that can go 100 meters, and it can give you the full 10 gigabit Ethernet at 100 meters. So these are the different categories of cables that we have that we can use for network. That's basically twisted pair cables that we can use for our networking. And like I said earlier on, twisted pair cables come in two main types. We have the on-shoulder twisted pair, that's the UTP cables, and then we have the shoulder twisted pair, that's STP cables. So you see a clear distinction between the two of them. With our on-shoulder twisted pair, you're likely going to have these things in there. So you have, with a category 6, it has this plastic in the middle, and then you have the cables are twisted together. They are twisted for a reason, which I'll talk about shortly. Then you have the shoulder twisted pair here as well. Now, why shoulder twisted pair? Can you give me a minute? Oh, jeez. Which process? I beg. Let me finish my class. I beg you. I can't. Just close it. If you don't need it, let me call you back. I beg you. Okay, sorry about that. Okay, sure. So you have on shoulder twisted pair there. Now, what's the major difference, or why the need for these twists that we happen to see inside our cables? Now, we have something called EMI. I think a minute. Let me. I'm just trying to check if it's there. I think it's not. Okay. So we have something called EMI, and that's electromagnetic interference. They have RFI, that's FRI, that's frequency, something interference. I'll check the actual word and get to you. But the very common one you hear is EMI, that's electromagnetic interference. Now, usually when electricity is generated through a cable, it has some magnetic fields that it cannot generate. And in a typical example like this that you see there, if these cables are not twisted, that magnetic field generated will have an impact on the data that is sent through this cable, and it will start changing the ones and zeros. So you have this magnetic, the magnetic twist, the twister there to help you kind of even out the magnetic interference that it creates out there, right? And with the plastic you see inside the category 6 cable, it helps separate the cables together so that it even gives you a better EMI resistance. Okay. Now with the shoulder twisted pair on the other hand, which is this cable that we see here. Now with this particular cable, it's quite expensive because it has an additional protection from EMI. Being it that if I have to run, sometimes we would have to run a cable through a ceiling or a plenum that already has wires in there. So let's say it's an old building and you're doing wiring. You don't want to maybe use trunking and stuff. You have to run it through the ceiling, and there are a couple of other electrical wires there. In that scenario, I can't use the ordinary shielded twisted pair because I'm going to have a lot of interference with the cable. And interference is a big deal because then as we go along, we'll learn certain things. But you realize that the more interference I have, which means anytime data gets to the destination and the checksum is checked, the PC realize that's not the correct data. It will request for it again. So that makes your network super, super slow. You'll be surprised. You go like, how come I'm in a LAN? Maybe I'm just sending data from a server to another PC, and it's taking all of this time because probably there's a lot of interference going on the cable itself. So in scenarios like that, that is where these shielded twisted pair cables basically come in kind of handy. Okay, so then because they have that extra foil around it that protects the cable inside, right? They are still twisted too. They just have that extra additional protection from EMI interference. Okay. Now, when we have twisted pair cables, before we can use them, we would actually have to terminate them, which means we'll have to put connectors at the end of the cable. Now, the connectors that we can use are called the RJ45. For the telephone cables, we call them RJ11. They are a smaller type of cable. We have different types of connectors, but these are the very common ones you would use in your twisted pair configuration. So you can see them there. There's an RJ45, like you see in this other image. There's also an RJ45 connector, which we would have to put at the end of a cable. But then I know you'll be wondering, how do we decide? How do we terminate these things? Do we just pick it up and jam it on the cable? No, it doesn't work like that. There are standards which we have to follow. So in as much as there's a wider Ethernet standard, when it comes to cable termination, we equally have a standard that we follow. And that standard is the EIA or the TIA 568. Now this is a B, but then there's also an A standard. Okay, the B happens to be the very common standard you see out there. Now, what the standard seeks to do is it defines how your cables are supposed to be arranged before the RJ45 connector is terminated to it. Okay. Now, if you look at the diagram you see on my screen, you have pin 1 and 2. That's the first pins, 1, 2. They happen to be your transmit positive and your transmit negative. Then you have pins 3 and pins 6. Here they are. So 3 and then 6 here. These are your receive pins. So it's your receive positive and your receive negative pins. That's the arrangement. So always know pin 1 and 2 is likely going to be transmit. Pins 3 and 6 are always going to be your receive pins. Okay. Now, if I want to terminate a cable or I want to design a cable, this is how the colors actually look like. That if I'm going by the 568 B standard. So the very first cable in the line, that's when I'm arranging them, is orange, white. The second cable happens to be orange. The third cable happens to be green / white. The fourth cable happens to be blue. The fifth is blue, white. The sixth is green. The seventh is white, brown. And the eighth one is brown. Now, I would have a video linked to my YouTube channel so that you can see how, those of you who don't know how to do the cable termination. I might not be able to do it live here. It might actually take all of our time. So I'll do a separate video, post it. So if you want to learn how to terminate cables, you can actually do that, right? Or probably you look at it, then the day we have a chance to come to the center, we try these practical hands-on. So kindly note them down, the things I say we'll do when we meet. So when we meet, at least we can take them one after the other and then we'll do all of them, right? Sure. So this is how we design cables following the standard. So if I choose 568B, this is how the cable arrangement or the wire arrangements are supposed to be like. So I have white, orange, white, blue, white, green, blue, white / blue.
Orange.
Yeah, like that kind of a style. All right, so this is 568B. Okay. And always know that the pin starts from 1. That is, if you have the terminator metallic pins facing you, know that your pins would always, the pin 1 is to your extreme left, whereas pin 8 is to your what? To your right. Okay. Sure. So let's proceed. Now, per cabling standards, we have 3 main types of cable designs that you can actually do. We have the straight through cable, we have the crossover cable, and we have the rollover cable. But the common tool that you are likely going to come across happens to be the straight through and the crossover. Now, when we design a straight through cable, this is how it looks like. In a straight through scenario, pin 1, the cabling standards we pick for one side of the cable happens to be the same arrangement for the other side. So if on one connected as on one RJ45, I have the orange, white, orange scenario like you see here. This is a standard 568B arrangement on one end, and I put the same arrangement on the other end of the cable. That is what makes it what? A straight through cable, which means my pin 1 and 2 would be my transmit pins, and then my pins 3 and 6 would be my what? My receive pins. That's my RX pins. Then that is a straight through cable. Okay. Now a crossover cable, on the other hand, looks like this. In a crossover cable, we cross the pins out, meaning on one side of the cable, I would maintain the 568B standard. On the other end, I would have to do a 568A. In a 568A standard, everywhere you see an orange, you replace it with a green. And everywhere you see a green, you replace it with an orange. So you can see that it crosses out, which means one side of the pin, my transmit pins would be what? Corresponding to my receive pins. And on the other side, my receive pins will be corresponding with my what? With my transmit pins. That's a crossover, which means you are just crossing over the cable. So that's how the diagram looks like. I think it's very fair and straight. Let's have a look at RJ45s that have been terminated in this manner. So you can see it there. So this is a straight through cable. It means both sides you maintain the same what? The same standard. So 568A, you can see orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. And it's the same thing here. When we come to the crossover cable, we have 568A on one side and 568B on the other hand. So you can see this is starting from what? Green, white, green, orange, white, blue, blue, white, orange, brown, white, brown. But this one starts with what? An orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Get it? So that's the difference. And that's what makes a cable a crossover. And that's what makes a cable what? A straight through cable. So when we are designing our cables, we know how to do them. Now, I know you'll be wondering why the need for these things. Why would I have to have a crossover, or why would I need what? A straight through cable. Now, it is because of device communication, because all devices have their own pins for communication. So if you look at things like this, so let's look at the chart. For instance, when I pick devices like a router, routers transmit using pin 1 and 2, and they receive using pins 3 and 6. Firewalls equally transmit using pins 1 and 2 and would receive on what? 3 and 6. PCs also will transmit on pin 1 and 2, and they would receive on pins what? 3 and 6. However, when we look at switches, it's a different scenario. Switches would transmit on pins 3 and 6, and they would rather receive on pins what? 1 and 2. So this creates a problem. So you should know that if I have maybe a router communication, depending on the cable I choose, the communication might not take place. You get it? Because if I'm connecting, let's say, a router to a firewall, and I pick a cable like a straight through cable, what is going to happen? The communication will not take place, because in a straight through cable, which means both of them already transmit on the same pins and they receive on the same pins. So there's no way that they'll be able to what? To communicate. You get it? So that is where the cable designs come into play. So for instance, for something like a router to router connect communication, I would use what? A crossover cable. Why crossover? Because the pins are crossed, which means this guy will transmit using pins 1 and 2, but this guy would be receiving. So when he transmits the data, that received data will be going to this guy's pins 3 and 6. And then the same thing, when this guy transmits on 1 and 2, he'll be receiving it on its what? Pins 3 and 6. That is why we use crossover cables. The same thing applies to what? Switches. Now, you know, switches is the other way around. Switches transmit on, switches receive on pins 1 and 2 and transmit on 3 and 6. So then it's the same thing. If I use a straight through cable, there's no way these two switches would be able to send any data across. So we'd have to use crossover cables. Then we are crossing the pins out. So data can actually go back and forth. And the same thing applies to what? To our PCs. We would equally have to use what? Crossover cable. So note this. Anytime you are connecting similar devices, you would have to use what? Crossover cables. The similar devices, we can use what? Straight through cables. And please, there's a catch here. When I say similar devices, not only by terms of look, but then from the chart we saw earlier on, we've noticed that a router, a firewall, a PC, they are the same device. Right? They are the same device. So if I'm connecting any of these things together, I would have to use what? A crossover cable. So if I'm putting maybe my router to a PC, I would have to use a crossover cable. Okay, so let's look at the other scenarios. So here, so that's it. So you can see PC to router is still a crossover cable. But then a PC to a switch, I can use a straight through, because these devices receives transmits on 1 and 2, receives on 3 and 6. But this guy, what? They receive on 1 and 2 and they transmit on what? 3 and 6. So then a straight through is fine. The same thing applies here. A router to switch connection, I have to use what? A straight through cable. Right. Now, I know this might seem like a lot of work, because you'll be asking yourself, it means, do I have to have specific cables lying around all the time? Not really in this day and age, because manufacturers have been able to come up with good technologies, and we have this thing called Auto MDIX. Now, what does Auto MDIX do? It's a feature that comes with almost all devices these days, and it allows them to automatically correct the pins. So meaning I can even pick a straight through cable and apply it for maybe a router to router scenario. The router automatically detects what cable you have used, and then they flip the pins so that then the communication would go on properly, right? That's what Auto MDIX is. Now, however, it doesn't come with every device. So before you do that, try and know if the device has that feature. Otherwise, it could throw your network into disarray. So, but to be on a safer side, if it's a new network you are deploying, try and stick to the standards. That way, you know you are not going to have a lot of issues on the way, right? But then always know there is this feature out there on most of your modern routers and switches to aid you do a lot of things.
How do you get to know that the device has this feature or not?
On it. When you check every device has a spec sheet, the specification or the data sheet as we call it. When you pick a data sheet, you know all the features that the router supports. You know all the features that the switch supports. Let me see if I can quickly pull one for you to have a look at it and see how it looks like. Let me quickly get one device I know supports that. getting one here.
Oh, okay.
I'm not
And
getting.
just
Okay.
it's clear. I understand.
Right, you understand, right? Yeah, sure. Just usually when you check on the box of most of these devices you buy, the features like list is there, and you see what it's all about. It tells you everything, right? Okay, so that's fine. So we can go on, right?
Yes.
Okay. So apart from twisted pair cable, we have a different set of cable that also comes into play, and that happens to be your coaxial cable. Okay.
Was
Now, yeah, the coaxial cable. Now we know
mhm.
these cables are not really um, used in computer networking these days, but then back in the days where they were actively being used for computer networks. These days, the applications we would see them being used for would be your cable television or your cable internet, right? So things like a DSTV, those type of connections. That's where you are likely going to see these coaxial cable. And in those applications, the common type of cable you see is the RG6, and most of them would have the F type of connector. This is a very common connector I'm sure most of us have seen at home. Most of your decoders have this connector at their back, right? So that's what we call the F connector. Now, however, when we speak of wireless, we'll talk of coaxial more because now they are used more in the RF industry where we are using them as in our antenna deployment than would use them to actually send data to other devices. So in the antenna applications, you're likely going to see these types. You have the LMR 200, LMR 400, LMR 900. And we have many other connector types that comes with. I'm sure when we do wireless, we might touch more on these things where you see that we have different type of connectors, the SMAs and all of these other connectors will be there. We have, I think, BNC and all those other types of connectors. You see them out there, right? So that's all for coaxial cables. There's no need to really spend too much time on it, right? Then we can look at serial cables. Now, serial cables tend to be more proprietary type of cable. Okay, if you see this blue cable here, the one you see on this side, now there's a proprietary cable from Cisco. It was very common back in the day. So all our serial connections on most of our the serial interfaces on our routers had to be connected with these type of what cables. So I plug this in here at one side. The other side is actually going to have the pins. It's a very blue long cable that we used to use. But these days, you're likely going to find an RJ45 type of a serial cable. Now, it is still going to be twisted pair cable. The interface is going to be RJ45, just that the cabling design is way different, right? So you can Google for this, the DS1 cable, and I'm sure you come up with, you see how that cable design goes. But the V35, this basically represents the blue cable you see here. They come in different variants, and I'm sure if I have to pull a page out here and we do V35, let me see. If I do V35, yeah, we see them here. They come in so many variants. You get it. There's so many different types of serial cables. You get it. You have this type, you have that type. So many of them, different types of proprietary type of what of serial cables. Okay, and we used to deploy them in areas where formerly when I have a Cisco router, the connection that comes from my one connection, you would see here, like this box you see here. Let me take this image if I can see it very well. Yeah, sure. So if you see this box you see here, this is a router and this is a DSU box. Okay, and the connection usually from your serial connection. So you see the bigger side plugs into your DSU box, and then you would have the other side connecting to the router itself. You get it. But this is quite an old technology. You don't see it out these days because with this box, what happened was you find your service providers dropping this box in your house, and you have to directly connect your Cisco cable to it. But how did you find it these days? These days, most of them will drop the DS1 cables instead of this V um, 35 type of cables. Let's see if we can see something with the DS1. Okay, this is telling us something totally different. But I'm sure when you Google it out, you are likely going to see. Sorry, I'm supposed to qualify it. I'm supposed to have DS1 serial cable. Right. So thank you. So you can see this is a typical example of one. You can see one end is actually what an RJ45. Right. That's one you see there. Right. And it's a similar thing they use in their console cables. You see, one side happens to be a RJ45, and the other side happens to be a serial cable. So these are things that you're likely going to come across. Right. I believe it's clear.
Mm.
Okay, sure. So let's continue. So that's it for our serial cables. Now let's look at fiber optics. Okay, fiber optics. Today it's all about cables. It's all about how we connect our devices. So when it comes to our fiber optics, with fiber, there's a different type of technology, and this is where we are actually transmitting data, relying on what? Light pulse. Okay. Now, if you look at the switches here, I think we saw this switch earlier on. This is the Catalyst 9200. If you see these empty slots, this empty slots you see here, these empty slots you see here are to accommodate what? SPFs. These things you see, we call them SPF transceivers. That's a small form factor pluggable. That's what SPF means. Okay. So these are little, I'll call them devices you would buy. And even if you look at this router down here, it has a couple of empty holes. These holes you see here. It allows you to plug some of these SFP transceivers into it, and then you can actually get what you want. Give me a minute. Let me show you. I don't know if you would be able to see it, but I don't know if you can see this. But this happens to be all right. This happens to be a Cisco switch, and if I don't know if my camera is focusing properly, but then if you look at it, this bigger hole you see here, this an SFP transceiver port. You get it? So if I want to add fiber connectivity to this switch, I'd actually have to put in one of those SFP transceivers, and then I can use a fiber optic on this particular switch. So this is a little switch. This is a Catalyst 2960, but a small one. This is an 8-port version of it, right? So we're good. Okay, sure. So let's go on. So when we look at fiber, we basically would have different type of cables to deal with when we're looking at fiber optics. Right, we have different type of cables to deal with when we look at fiber optics. So you can see, we'll look at them pretty soon, but then you have these type of connectors, and you see most of them come in what? In pairs. It's not just one, because usually with fiber optics, you are sending on one port, and you are with one cable, and you are receiving on another cable. That's how fiber optics would usually work. That's why you see them coming in what? Different pairs most of the time. So that's a clear scenario of fiber. So always know this: in most of your fiber optics scenarios, you would have your TX. So it means on one side of a router, I'll have a TX going to the RX, and then the other guy will have a TX coming to my RX. That is why you'd always have what? Two different cables being connected in the fiber optic scenario. Now, let's look at the cable structure of a fiber optic cable. So in a fiber optic cable, we have the first one, which happens to be the fiberglass core. That's where the light pulse is actually transmitted, right? That's where the light pulse is actually transmitted. Right? That's where the light pulse is actually transmitted. And then we have the second one, which happens to be the cladding that reflects the light. This second thing you see here, that's what bounces the light back and forth for it to be sent here. And then you have the protective buffer to secure these things so that the fiber core doesn't break actually. And then you have the outer jacket of the cable, the bigger thing. It might be black, usually a very thick cable. Try as much as possible to protect this so it doesn't break. I don't know if you have ever seen a fiber optic cable before. I used to have one lying around. I don't know where I've placed it, but you don't really see much of anything. It's just a fiberglass core in there, and then there's a rubber coating around it. Okay, so that's how it looks like. Now we have two different types of fiber optics. You have the single mode fiber, and then we have the multi-mode fiber. Now with the single mode fiber, here we have just a single fiber core, and everything goes through in a single fashion. Usually the fiber core tends to be a very narrow type of what? Of core. And then when it comes to the multi-mode fiber, here we have usually multiple fiber cores where the light is just bouncing all over the place. Now this tends to have a much more, a wider fiber core. And this is the thing, usually with the multi-mode, the technology we are using here happens to be LED lighting, whereas with a single mode fiber, they use laser lighting. So these cables are much more expensive than these ones, and they all have their use cases, right? They have the scenarios which would permit you to use them, right? Okay, good. So let's see the scenario that would let you use them. For instance, these are two buildings. Okay, so I have building one, I have building two. Here I have one switch on the ground floor, and then I have a second switch probably on the third floor. Now on the other side, I have one switch sitting somewhere on the ground floor, and the second switch is somewhere on the sixth floor. We already know the limitations that comes with copper cables, that's twisted pair cables. They can go a maximum of what? 100 meters. So in a scenario like this, the preferred cable of choice that I'm likely going to be using would be what? A fiber cable. So I would have to use a fiber cable to connect them, because I'm sure running a cable from the ground floor up there might be more than 100 meters. And the same thing applies here. And the cable that we are going to use, this would basically be what? A multi-mode fiber core. These are for what? These are for um, shorter distances. Then when it comes to connecting the buildings themselves, because these buildings might be probably a couple of kilometers apart, that's where we can use a single mode fiber, because then this can go longer distances as compared to what? To these shorter ones. So these are multi-mode fiber, and that is a single mode fiber. So those are the use cases, or those are the scenarios which should basically permit you to use to do any of those things, right? Are we good? We are good, right? Sorry, let me try and move.
Yeah, I'm good.
Okay. Ransford, I guess you're also there. Are you following?
Yeah, I'm following.
Okay, sure. Okay, sure. That's great. Right. Okay, so that's all about fiber. But then let's look at the standards that actually define fiber itself. So we have Ethernet standards that happens to be, you have our Ethernet standard. So we have 100 base. So the very first type of fiber we have is the 802.3Z. You realize that it's still Ethernet. That's why you see 802.3. It didn't change to any other name. So that tells you this is an Ethernet standard. And the informal name we get for this is 1,000 base LX. Get it? So this is telling you the 1,000 here refers to the speed you get. The base here tells you it's a base band, and the LX here lets me know the type of what fiber optic cable that I'm basically going to be using in there. And then we have the standard there, the speed is 1 gigabit, and the cable type. So you can use either multi-mode or single mode fiber. And the distance, if I'm using multi-mode, I can go only up to 550 meters. But if I choose to use a single mode, I can go up to 5 kilometers. Right? You see the difference there. Then we have the 10G base. Now, what I want you guys to do is I want you guys to figure out what these things are: the LX, the SR, the LR, and the ER. Kindly figure it out, and you let me know probably in the next class, or you just post it somewhere. Right. So we have the 1,000 base SR. That's the standard. That's 10 gigabits fiber, and it's multi-mode. It can go 400 meters. Then we have the 802.3EA, which is so this is the LR. It can go 1,000 gigabits. It's single mode for about 10 kilometers. And then we have the EAE, which would go basically single mode equally 30 kilometers. So these are the fiber optic standards we have. There are a ton of different other standards out there, but then these are the common ones that people would use, or most network engineers are likely going to be concerning themselves with. Now, when it comes to the connectors, we saw so many different types, but then the major connectors we would see for fiber are the ST connector, which is the round one, like you see here. We have the SC, which is a little bit square-like, and then we have the LC, which is this. Now, please, all fiber optic connectors are not the same. So if I have an SFP, that's an SFP transceiver, and I'm going to connect anything to it, please be mindful to know what type of transceiver you have before you go out to buy the connector. Otherwise, you buy the connector and it won't fit that particular transceiver. So always know the transceiver goes with the connector type that you have. So if you decide to buy one, you know what exactly you are buying, right? Are we good? We're good, right? Okay, so let me go on. Now we can jump to wireless. Okay, we can jump to wireless. I know this seems to be a very long slide, and I've been talking a lot about so many things, but then it's all the knowledge you basically need. So please bear with me. All right, so let's look at wireless. So wireless Ethernet is its own what standard. Please know the difference. We have Ethernet, and then we have what? Wireless Ethernet. They are two different things. Don't confuse the two of them to be the same thing. They are not. Okay, so we have this. Wireless Ethernet is defined by the 802.11, and Ethernet is defined by what? 802.3. So can you know what the difference are? It's a very tricky question that seems to pop up all the time in your exams, right? So when it comes to wireless, works within a spectrum. Let me put it that way, right? Everything wireless, not just Ethernet wireless, but then everything that uses radio or frequencies work within a spectrum. And these are the spectrums that we likely find ourselves in. So we have the extremely low frequency spectrum to the very high frequency spectrums that cause radiation. But then our how do you call it? Our wireless operates somewhere within these microwave frequencies. It's around this range. That's where you find your wireless basically operating at. Okay. Now, wireless would always deal with what? Channels. So when I pick a spectrum and I pick a frequency I'm dealing with, you basically have channels in there to actually work around with, and that is where they fall. So channels basically are the range of frequencies used to what? To transmit information. So that's why we have radio frequencies. Even at your cell sites, I'm sure they have their own frequencies they operate in. But then when it comes to wireless, we have a major spectrum that we use. So you find wireless operating in the 2.4 gigahertz. I know there's equally 5.4 gigahertz spectrum. So these are the spectrums that we use for our wireless, okay, where all the other things come in. Now, when we pick a spectrum, when we look at the 2.4 gigahertz spectrum, this is what basically happens. You have all the way from 2.4 gigahertz all the way to 2.499 gigahertz. Now, inside this, we have various channels that can be used. So the entire spectrum is divided into 14 channels. However, the only channels we are likely going to be using are three: channel 1, channel 6, and channel what? 11. Okay, so when we are configuring our wireless devices, it's very important that we know which channel we are placing the device in, so we don't end up overlapping with other devices. But more on wireless, when we treat wireless as a topic, we'll dive more into it, and then we'll cover a lot of things about this whole spectrum and wireless thing. This is just an introduction of the standard. Okay, now we also have the 5 gigahertz Wi-Fi spectrum, which we use, which tends to be a much more wider and bigger spectrum, going all the way from the 5.170 gigahertz all the way to 5.835 gigahertz, right? So it's a quite bigger spectrum as compared to the 2.4 gigahertz, but then it equally has its own limitations. Okay, so these are the divisions of what we can. Now, in as much as it's a very big and a wide spectrum, we are not allowed to use everything. So the very common ones you would see enabled on most of the devices you would work with will be ranging from the channels that's the 36 to 48, and then the 149 to 161. These ones here are reserved channels. They are not really what used, because they are reserved for military applications. These particular ones, these two channels you see, all the ones, so anything from 52 to 64 all the way to 140. These channels are they are reserved for military applications, but it doesn't mean you can't use them. Before you use them, you require how do you call it, specific equipment to be able to use these kind of devices. And before you do, you'd have to make sure that you have to check and make sure there's no military usage of any of the frequencies there before you use them. But then for your normal consumer home use, you can use any of the frequency or any of the channels between the 36 to 48 and then 149 to 161. This is very important. When you're configuring your devices, it's there. So you have to actually look at it so you don't end up creating issues for yourself. Right. Okay, so let's look at the various wireless standards that we tend to have out there. So the standard itself is 802.11, right? It came out somewhere in the 1997s, and it has evolved over the years. Initially, when it came out, it was geared mainly towards the enterprise market, but over time, it has been given out to the consumer market. So we had the 802.11a and the 802.11n. These were mainly geared towards the enterprise market. Then for the home consumers, we've had the 802.11b, 11g, 11n. This is geared towards the home. I know this isn't the first time you're seeing this, but I'm sure you might have come across it. When you're buying your phones, you're buying your laptops, and you check the Wi-Fi specifications, you see all these alphabets attached to it. I'm sure you've never really bothered to say, what is this thing that I see all the time? It means a lot of things. Every standard you see there has its own specifications and implications for you as an end user. So let's look at some of them. So for instance, with the 802.11a, this is the spectrum it uses. It uses only the 5 gigahertz spectrum, and it can give me speeds of up to 54 megabits per second. Right, initially designed for enterprise use only, but over time it has changed. Then we have the 802.11b, which basically uses the 2.4 gigahertz spectrum, and it can give me up to 11 megabits per second bandwidth, and it's used for small office, home office use. So this was very popular in our homes back in the day, but then these days at least we have better ones, right? Then we have the 802.11g, which also uses the 2.4 gigahertz spectrum. And however, that is 54 megabits bandwidth, and it can be used both in enterprise and our home environments. The reason being, it has much better speeds as compared to the 11b, right? Then we have the 11n, which crosses spectrum. So 11n is both 2.4 and 5 gigahertz spectrum. So you can have them in here like this, right? And it can work with speeds of up to 300 megabits per second, which is quite a good speed, okay? And it can do MIMO, which means it's bidirectional. You can do things like that. Then you would have the 5 gigahertz, that's the AC, which is a very relatively new one. If you have a very recent phone, I'm sure when you check the specs, I don't know what phones you guys have, but then please do check the Wi-Fi specification and you would find out what it supports. And even your laptops, you can equally check the specs of your laptop and tell me what standard of Wi-Fi your device is equipped with, right? So we have the 5 gigahertz spectrum, that's the AC, and these are the speeds. That's amazing speeds. That's giving you probably gigabit Ethernet speeds, right? So that's 1.3 gigahertz bandwidth, and you can do beamforming and all of that. More of this MIMO and beamforming when we treat wireless as a topic, right? So this will bring us to the end of this particular model, which is cables and connection types that we basically have. Now, in this particular model, we have reviewed some Ethernet protocols specifically that has got to do with cabling. We've looked at some different type of wires we have that basically are twisted pair, our coaxial, and our serial. We've also looked out at the wireless. We've also looked out at wireless, and then we've looked at wireless, yeah? Yeah, fine. So that's basically it. Now, I want to apply a different tactics when it comes to our quizzes, okay? Yesterday, I asked for your emails. Okay, not everybody. I think, Ransford, I didn't ask you for yours, but kindly do send me your email, let's say via WhatsApp or something. What I've done is I've created a Google Classroom, and I would want to put all our assignments in the Google Classroom. So the quizzes will be per model. The labs would equally be posted there. So usually after the class, you just go to the Google Classroom and then you complete the quizzes for me. That way I get to see the answers and then everything will pop up. The labs as well will be there. So you can always download the lab file. If you're supposed to do it in Packet Tracer, you do it, and then you can equally turn it in there. You can turn it in as a Packet Tracer file. Maybe I would create a small video on how to do that, then post it in there. Right, and create a small file. Can you hear me? Can everybody hear me, or it's gone? Ransford, can you hear me now?
Yeah, I can hear. I can hear.
Okay, that's Eric. Yours is fine, but I think Ransford can't hear me. Let me ask him if he can hear me. Ransford, are you there?
No, I can't.
You can't hear me at all.
I don't know.
Wow, that's weird. But I can hear you when you talk. I'm using an earpiece. I can hear you. I can hear you. So how is it possible that you don't hear me? Let me see what's happening. But here it says I'm fine. My I don't know if you can. If you're using an earpiece, just disconnect it and connect it back. You can't even hear me as well. Okay, so disconnect your earpiece and connect again. Okay. Okay, so Fred, you can hear me. Ransford, is it fine? Can you hear me? Okay, so once when it's fixed, then you can hear me. Let me know. Okay. Now, however, so like I was saying, now we might not be doing the quizzes like you saw here. I think I have a quiz here like this. I don't want to be doing this with the class. So what we can do is I rather put all of the quizzes on the Google Classroom, which I think I've invited all of you. Those whose emails I have, I think I have. Fred, I've invited you. Eric, I've invited you, but I think you haven't responded. None of you has actually responded to the invite yet. So kindly check your mails. If you gave me a Google email, I think I have put then I've sent you invitations. You would have to, if you want to use it on your phones, you can easily download it. I think when you go through the process, it would ask you to finally download the app and keep it on your phone or something. But then you can still use your PCs through the web browser, complete the quizzes, do the labs, and then you can equally send them back again to me, and we can work with them. Are we good? Is everybody good? If you can hear me, kindly let me know. Whoa. Can't seem to hear all of you. Or can you all hear me? That should be the question.
I can hear you.
Oh, okay. Okay, fine. So that's what. Okay. So you just let's do these two quizzes you see on this. I think there's about 2 or 3 of them. Let's complete this one. You do the rest for me on the Google Classroom page. So if it says which of the following Ethernet standard defines gigabit over UTP? So which of the standards defines gigabit?
Gigabit.
Is what?
Gigabit.
So what was the?
It's A.
It's A. Are you sure? Read that. Let's read the question again. It says which of the following Ethernet standard?
Yeah, I can't even hear. Plenty things at a time.
I know. Which of the following Ethernet standard defines gigabit Ethernet over UTP cable?
Gigabit Ethernet over UTP. I have to take a closer look at this.
Okay, it's a very simple answer. It's there. When you look at the 3
but UTP.
So gigabit is 1,000.
Ah.
Yeah, so the answer is actually C.
It's C. Eh?
Yes. So gigabit is 1,000. So you can see 1,000 base T. The 10G base, that's for what? 10 gigabit Ethernet. And then when you see 100 base T, that's for fast Ethernet, which is 100 megabits per second. Right. So the correct answer in this scenario is 1,000 base T. We're good. Ransford, are you there? Can you hear me?
Yeah, I can hear you now.
Okay, sure. Then that's fine. Okay. So please don't forget to send me your email so that I can send you the invite on Google Class as well. Okay.
Okay.
Okay, sure. So now the next question says, which of the following is true about Ethernet crossover cables for fast Ethernet? So pins 1 and 2 are reversed on the other end.
Okay, have a nice day, boss. Yeah.
All right. Then pins 1 and 2 on end of the
ears are now free. Oh, my destiny is active here. Sorry. I'm in between 2 meetings, so this person like plenty sounds at the same time.
Okay.
Okay.
Just mute your mic. So the mic, yeah. Okay, sure. So pins 1 and 2 on the end of the cable connect to pins 1 and 3 on the other end. So which of them is true actually? For question 2, it's talking about crossover cables. Which of the answers there seems is B? Yeah. Let me see. So B says what? Pins 1 and 2 on one end of the cable connect to pins 3 and 6 on the other end.
3 and 6.
Yes. So the answer is B, which is correct. Right. Sure.
Yeah.
Yeah. Okay. So that's it. So the answer is B. Okay. Good. So I think the last question is this, which will be
the following advantage of multi-mode
fiber link instead of what? UTP or single mode fiber. So why would I want to use a multi-mode fiber instead of what? An Ethernet link, right? 1, so we have to achieve the longest distance possible for that single link, to extend the link beyond 100 meters while keeping the initial cost as low as possible, to make use of the existing stock laser based, blah, 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 blah. Now, the answer is B, okay. The reason being that, yes, fiber optics basically will give me the longest distance. But then, in this scenario, it's asking for the major advantage of using multi-mode fiber specifically for an Ethernet link instead of a UTP or single mode fiber. We know single mode fiber is good. It would also give you a long distance connection, but then it's very expensive.
Long distance, yeah.
Yeah, it's very expensive. Yeah. That's why A is not applicable, and the best answer would be what? Would be B, because then with multi-mode fiber, it is cheaper and it will still give us a better distance over UTP cables. We are good, right?
UTP, yeah.
Okay, sure.
Yes, yes.
So you continue the rest of the quiz on the Google platform, and then we see them. Okay, it's graded. So when you're done, you see if your answers were correct or wrong. It'll tell you everything. Okay, this is our lab work for this particular model. And all it requires you to do is this. We would have to redraw the same thing again, and then we would have to connect. So it says connect the network devices together according to the labels. Use the appropriate type of cables. For practice, assume that auto MDIX is disabled or not supported on these devices. So this looks like a very big topology, but then what it's saying is, this is a router. So if you are going to connect the two of them and see what is there, the description, it says this is what 3 kilometer distance. So how do you connect them
3
together?
kilometers. Okay.
Yeah, you get it. Automatically, you can't use what a UTP cable here. So then you should know what type of cable will go. Then this is R1 and R2. It is 50 meters. What cable will I use? This is R3 and 4. It's 250 meters. However, I know here and here is both fiber, but in packet tracer, you don't have the chance to differentiate whether it's a single mode or multi-mode. So you can use fiber in both places. Okay. Then you have your switches here as well. So we connect them at least. Likely the switches do not really have any distances. So we just do our connections and see how it fares, right? So you draw the same thing in there, then you can save it as a packet tracer file, and then you turn it in. Okay. Just take your time with the Google Classroom. It's a very simple platform too as well. If you just take your time around it a little bit, you'll realize how to send things there. But then this file will be there as a PDF. Okay, this particular slide, it would equally be there as a PDF. So you can look at it and then you do the work for me. Are we all good?
Yeah, we are good.
Okay.
We are good.
Okay, so I believe we can proceed with one more topic before we call it a day. It's not yet 10, so we have about 30 minutes more to go. And we can do one more thing, right? Or you guys are off to something?
No, I'm
Let's
cool.
go.
Can we go on? Or Ransford, you have to attend to something.
Oh no, let's go on. Let's go on.
Okay, sure. So
I've rescheduled it.
Okay, sure. So then let me just quickly continue then. That would help us go a little bit faster as well. Okay. Sure. So
how do I do the remote process? How do I do it?
okay. So the next topic for today basically would be Ethernet operations. It's a very short one. It's not a very lengthy slide. So once we are through, we can call it a day. Okay, so we have this here. Okay. So this slide would seek to, it still speaks about Ethernet in a broad spectrum, although we have already spoken about much of it, but then it would just do a little bit of history about it. And then we look at some particular technologies that has got to do with Ethernet as a whole, right? So we have, good. So a brief history about Ethernet, okay? It was actually developed in 1973 by a guy called Bob Metcalfe. Okay, he was experimenting with certain things, and then he was able to come out with a standard. But then until 1978, it was just a steady something. So it was implemented at the White House. Okay. Now in 1982, the very first standard was defined. That was the 802.3. Okay, that was when it was actually defined and all the specifications were also set out. Okay. Now, over the years, we have had various milestones. So realize in 1995, we had the fast Ethernet come up. We've had the gigabit Ethernet. We had 10 gigabit Ethernet in 2002. We've had the 40 gigabit Ethernet, and then we've had the 100 gigabit Ethernet. I'm sure you'll be wondering, we're in 2020, you still haven't seen this around. Yeah, it's not yet out there, because even these speeds, we are still trying to comprehend it. So we'll eventually get there, but then just know these are standards that are already out there. In some years to come, you're likely going to be seeing them being rolled out with most of our network interfaces from the look of things and where we are going. Because now we are tending to need the speed, right? Okay, so I think I've already explained them. So let me just go ahead. Okay, good. Now, this is a very interesting aspect of Ethernet that we would all need to understand. We call it carrier sense, that's CSMA/CD. That's a carrier sense multiple access with collision detection. Okay. Now, when I have a domain or I have a network domain, like you see here, should I decide to send anything? In the very first versions of Ethernet that came, we used to have a single cable connection and every single PC was attached to it, right? And that was what we call the hub, if you remember very well. In the hub type of network, or this would represent a bus topology, let me put it that way. So we have a single carrier and everybody is attached to that particular carrier. Now, anytime somebody decides to send data, what you are actually doing is you are charging the line with 5 volts. So if, let's say, this PC here decides to send data off to another PC, it generates a 5 volt current and sends it over the line. And everybody, that's how it works, right? Now, per the rules, when he is done, he releases it, and then someone else, like this green PC, can also take the link and start sending another 5 volts. Okay. Now, with the rule governing CSMA is that you would have to listen to the line first. That's the carrier sensing. Any PC that decides to send data has to first of all listen to the line and check for an active connection. It means you are checking if someone else is using the line, if someone else is sending anything around. If nobody is sending, that is when you can actually decide to also send. But then this leaves us with a problem. Now, PCs, the green PC here might have listened to the line, nobody was sending, so it decides to send. Whilst the red PC here might have been listening to the line, nobody was sending, so it decides to send. When it sends, this is what happens. So red PC sends just around the same time, green PC sends. When that happens, you end up generating 5 volts from the red, another 5 volts from the green. This creates a total of 10 volts. 10 volts will cause a voltage spike on your cable. When that voltage spike occurs, we refer to as a collision. So if this guy sends and charges the line with 5, this guy also sends, charges the line with 5, the current becomes 10, and that's a voltage spike. And that would basically create what we call a collision. Now, when a collision happens, so you can see here, so we say a collision domain is a group of network devices that would simultaneously detect a voltage spike. So the moment the two of them do that thing, they are basically going to create that collision. And this is the rule. When a collision occurs, they will both cease the data transfer process. So it means this guy will stop sending, this guy will stop sending. And what CSMA will do is it resets their timers. So it might choose to give this guy, maybe it can give him some 10 milliseconds. And then maybe for this guy, it might give this guy 5 milliseconds. Now, what it means is now they will both try to send again, but this time at different specified times. So this guy would send at 5 milliseconds, and this guy would try again at 10 milliseconds. By that time, it will realize that, oh, somebody is sending. So it would hold on before trying to send. But then you can see where this is going. In a network like this, you're likely going to have a lot of collisions than anything else, because once in a while somebody to send, they'll collide again, there'll be a spike, they have to, that kind of a thing, right? So it wasn't the best type of a network scenario, but then this is what CSMA/CD basically means, right? Now, apart from that, we have duplexes, right? So we have full duplex and half duplex, right? So when we speak of half duplex is basically a one-way communication, which means in a network setup where you're using half duplex, only one device can speak at a time. So like here, only this red guy can send data at one time. When it is done, it's only then that this guy can also send data. Both of them can do it simultaneously. Now, in a full duplex scenario, both devices can communicate at the same time, like a telephone conversation. You realize when somebody calls you and you guys are talking, we can be talking back and forth. So if I'm talking, you can just chip in something. It doesn't break the call. Nothing happens. That's a full duplex type of what? Of a communication. But the half duplex is more like a walkie-talkie, like the police people. You see them with their radios and they would have to stop, listen before they say something. That kind of a scenario, right? Okay, so that's what you see here. So in a full duplex, only one device can communicate at what? At a time. So it's probably my switch can send, the PC has to hold on, right? You don't find them, the PC will also send what? Later on. That is how it basically works. And we can't have what? This kind of scenario where both of them try to send. If both of them tries to send, it's going to create what? A modern what? Collision domain, because it is one single line and both of you are trying to what? Send data at the same time. Your data would collide, thereby creating what? A collision domain. So that is prevalent, especially when you are working with what? Half duplex type of networks. But in our modern day networks, we have full duplex where we can have devices sending data at the same time and nothing really happens. Okay, and that is how most of our modern day devices would actually what? Work. Most of them would be operating at what? Full duplexes. Okay. Now, the standards that support them is what you see there. So anything from gigabit Ethernet requires you to use what? Full duplex. But then in the previous ones, like Ethernet and fast Ethernet, we could get away by doing half duplex and we won't really have what? Much of an issue. Now, this is going to be a lab work which won't come now. It will come later on. When we start doing our switch configurations, we'll learn how to configure the speed, and then we'll learn how to configure what? The duplexes, right? So know that in this particular lecture, there's no lab currently, but the lab will come in a subsequent classroom, right? So be still prepared to what we are going to be doing it, right? So all too soon, this brings us to the end of today's class, and hopefully I should see you tomorrow. Okay. There's a lab work though. Let me see. There's a lab work here. So that's a lab work. But that's a lab work I was talking about. But then we won't do it now. We will do it when I teach you how to assess the switch directly. Right now, I haven't taught you how to, so setting this might be difficult. So we'll come back to this lab work and do it. Right? Are we good?
Yeah.
Okay, sure. So that's perfect. Okay. Okay, so you can do the other lab. That's the one from the cables. That one I've shown you how to use packet tracer. Now, I know some of them might require you to put proprietary interfaces into the device. What I was doing yesterday when I didn't get the interfaces I wanted, you saw me dragging and dropping an interface. So I know with the fiber, the router doesn't support, it doesn't by default have a fiber interface. So you would have to put some in there. Try and figure it out. If you're able to do it, you just kindly would send it back to me. All right.
Okay.
Okay, sure. So thank you guys for coming for the class. And if you have any concerns, you can kindly raise them. You can send me a text message. If you have any difficulties or challenges, you equally let me know. Okay. Okay, sure. Yeah.
I want to know your page. What's the name of the page on YouTube?
On YouTube is
And
Jesse the Instructor. I think I sent you a link. Okay, maybe I might have to send it to the mail as well. Right. I'll send you, or let me just see if I can post it to you right now on the chat. I think that might do. Right. Yeah, let me.
because I have divided attention to.
Let me send you the. Let me send you the page. It's still work in progress though. So let me. Oh, why are you?
I hope we can record the class as well.
I think
So
I
that
gave
later
you.
on, if you.
I think I gave you the. I don't know if I've given the permissions, but I'll check the settings actually.
I tried yesterday. They said I have to seek permission from you
Permission for
guys.
okay, that means I haven't done that.
I think I need to be doing like revisiting because
Okay,
usually
but
I mean work meeting and then this one at the start. Sometimes I don't really
at the time too. But it's there.
understand.
It will be on the YouTube page. Every class we have, I'll post it there, so you can always see the class and watch it. Okay.
Let
Okay.
me see if I can see the page.
So let me just send you. Let me send you the link right now to the page so you can. So you can watch it. Yeah.
Yeah,
Yeah.
just
Yeah. I'm here.
so is it possible after this session you'll be able to write the external CCA?
Yes. Yes. Sure. It's possible. It's possible.
And these are the some of the questions that will come,
Yeah,
right?
most of them are. It takes that kind of a precedent of how the questions are set. But then before we are done, we'll actually go through the exam dumps. Actually, we'll get them, and then we'll go through it, so you have a feel of the real deal. But then I sent you the book as well. So as you read, the book also has questions at the end of every chapter. So as you answer them, like it all prepares you towards it. Right. Just send me your mail. I think when you send me, you see all the I posted all the resources in the Google Classroom, so you can download them and then be reading them as well.
Oh, okay.
Yeah, you can be reading them. So let me see. Okay, so I'm sending. How come I can't send?
Then I want to ask about the job market after you finish with the course.
The course? Yeah.
Yeah.
I've been I've been told the market is good though, but actually, if I search online, I know they see anything. I fear self.
The market is good. Just finish the course and start floating
Hey,
out. You'll be surprised. Like just finish the course and start floating it out. You would get it.
if you finish this course, we don't get job there, the move.
Oh,
Because the way people have encouraged me, like, oh, do it. The job market is good.
the job
And
market.
I finish.
You will finish and you would have a job. I can
Finish
guarantee that
and
for
then
you. The market is good. Not bad.
God, have mercy.
The market is good. It's not bad at all.
Because with this type of certification, I don't know if Ghana here, they really
Yeah,
see it as.
they do. They do. They actually do. Yeah, they do. So it's not like you won't get a chance, but they do. They do. It shouldn't really be too much of a problem. They do. Just finish. Once you have the certification, I know getting a job is not a challenge.
Yeah. And okay, you as we go,
Yeah, as we go on, I'm sure everything will be catered
as
for.
we go, yeah.
Yeah, sure. So just take her. Just you do your part of the bargain. Your part is to be reading and doing the thing. Once you are reading and doing all of that, yeah, it becomes easier for you. Right. So I think you can go to the channel. I think you try and subscribe. When you subscribe, you get to see, because most of the videos I don't make them public. They are private. So if you subscribe, you can get a chance to be seeing them as we proceed. Right. Okay, so yesterday's one is there. I'll put today's one there as well, and every other video. Yeah.
The video is private, unavailable, and it's not showing me the page.
It's not showing the video is not available.
Click on the, yeah, and it's not showing me the page, or is it? Let me reload it.
Reload it and it should be. In as much as it's not showing. Okay,
yes. Okay, maybe I can show you.
Okay, no. Let me see. I think I know why. Let me change it. I made it private. It's supposed to be unlisted. Let me change it. Okay. I get it. I get it. Let me just. I'll quickly fix it. I know what the problem is. Okay, let me fix it for you. I think it's. I know why. Let me just quickly fix it for you then. Okay, you keep the link. I'll fix it right now. Then you get it. I think it should be me changing the.
So
yeah.
At your end the courses. What's your last this thing over there? I think the last certification over there.
I think we can go all the way to we can go all the way to CCIE.
Oh, okay.
Yeah, we can go all the way to CCIE.
And you said the CCIE you can only take only one exams here in Ghana.
Is it what?
You said the CCIE. The CCIE.
Yeah, you can only take the written exams.
The only one here.
Yes, the other one you'd have to travel. The rest outside. Yes, you have to travel and write it. That's the 8-hour lab session. But with this whole Corona thing, I don't know if they would work around it. But I'm sure they will come up with a way of actually having the lab. Yeah, because I know for now most of their testing centers are actually closed. So they would. But anyway, I'm sure you're not writing the CCIE now. Once you finish CCNA, you do CCNA. Yeah. By the time you're ready, I'm sure.
For someone.
Don't worry about
how long will it take you to get CCNA? I say, this is someone who is really hardworking and wow.
Okay. Want to take CCNP, I would say
for our case, how long will it take us?
For your pace, I think if you really want to do it and know your stuff, give yourself like 2 years.
2 years?
Yes, or less. But
to get CCNP.
Yeah, that is to get the knowledge as well. But then for now, when you finish, you write the exams, you're good to go. You can learn. Okay, let's say give it 1 year. If you are very serious about it, I think 1 year is fine.
1 year is fine.
Yeah, 1 year. 1 year you should be able to do it. 1 year you should be able to do it.
The CCNA, last time I went to, I saw you have the CCNA, you have the security, you have the wireless, right?
Yeah, but then now that has changed. With the new CCNA, you don't have those specializations again. Now you just have one CCNA. It's when you break out the CCNP that you have there, you can do a specialization. Let's say you can go into wireless, you can do security, you can do collaboration.
Oh, okay. So the CCNA, that this one is only for routing and then social.
No, right? This one is general. Now they don't specialize again. So this is a general CCNA. That's why we have chunks of wireless in there. We have an amount of security. We have an amount of programmability in there. You get it?
Oh,
so
okay.
This one is like a generalized CCNA. So you can take it and it to give you a brief idea of every other this thing there.
Okay.
Yeah. Okay,
so the profession is the one that you specialize in?
Yes, the professional, then you can choose the path you want to go. Yeah. Okay. So that's fine. I think I'll fix the videos now. So Eric, I'm sure you want to try to play.
Let me reload.
Yeah, try reloading it and see.
We'll get there.
Yeah, you would. Yes. Definitely. It's just with hard work. Once you
yes.
Okay. So just try if you read it, yeah.
So on average, if you are able to steady, let's say 4 hours in a day, okay, on average,
yeah,
4 hours a day.
Yeah.
Okay, it's working now.
Okay.
Can you can it take the exams in 4 months time?
Oh, sure, you should. You should be able to. 4 hours dedicated. You're learning. You know your stuff. You should be able to take the hours in 4 months. The exams in 4 months.
Okay.
Yeah, you should be able to take the exams.
4 hours a day.
Yeah. It's all about your commitment. Once you are committed, you are learning, you know your stuff, you are doing the labs, you are going through the flashcards. You should be able to take the exams in 4 months.
Oh, okay.
Yeah. It's not too much of a hassle.
Because I have set a milestone.
Oh, okay. Okay.
Yeah, to take the exams in 4 months time.
Okay.
Yeah.
Okay. That's fine. We'll try and we'll work towards.
By November soon.
Okay. 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 That's fine. That's fine. We'll try our best to help you do that. Okay.
Okay.
Okay, sure. So I think it's been a successful class and we'll call it a day. Hopefully I'll see you tomorrow morning.
Okay, sir. Thank you for waking me up.
Thank you very much. You're welcome. Thank you. Okay. Thank you.